comes to the top of the base of the Statue of Liberty. And what's shown here is 240 feet of sea level rise, which is more than would occur if all of the ice in the world were to have melted. So there's inaccuracy illustrated here. But what about this? That's a silly example, it's a tabloid. But here's my Times columnist in Victoria, and it's on the science page. Ooh, science. And there's a map in the bottom, and it looks really scientific because there's actually a scale on the map, see here? And there's a transect with blow-ups and big science words. So you think, ooh, science, this, coastal flood feared. Here's our harbor, beautiful harbor, double-decker buses with the water artist's conception of the water sea level rise. And here you have an expert being quoted as saying a rise of 5 meters by Christmas is a very real possibility, published on November the 22nd, 1998. So, I mean, this is clearly absurd. It's impossible for 5 meters of sea level rise to occur in literally a month. So you'd have a month to move to high ground. And you can imagine that people reading this on the science page would have one of two take-home messages. One is, these scientists are a bunch of crazies. This is just nonsense. Who are these eco-zealots going on about global warming? Or two, sheer panic. And I received both of those phone calls on my answering machine from both types of people. But what it really is illustrating is a problem in the conveyance of science through the media, particularly on science related to social issues that are being discussed where policy might actually influence social behavior or vested interests, is a media person may or may not know who is an expert or who is not an expert. Just because I have a PhD in maybe neuropsychology does not mean that I'm an expert in, say, particle physics. And yet often that people can put forward ideas through press conferences or issuing releases to those who are less than critical as to whether or not they actually have some credibility to actually make those statements. So this is a problem, and of course it can be exploited deliberately to try to undermine public engagement on and support for various policies. Here's another example, though, and this probably is the most significant problem with the conveyance of science to the media, through the media to the public, and vice versa. It's the subscription of journalists to an ethical norm which says that they should not be perceived as biased in their reporting. Now, the media plays a critical role in a democratic society, 3 main roles. One is it holds our elected leaders accountable. 2 is it informs the people of the issues arising from a particular policy to let the people determine whether or not they support or don't support a particular policy. And 3, it gives the people a voice in our democracy through things like letters to the editor, phone-in shows, etc. So it's critical that you want to not be perceived as balanced in your reporting. That's not an opinion page, that's in the story reporting in this important role that the media plays. And I'll give a specific example. Let's suppose Canada, well it is entering a free trade agreement with China, and you've been tasked with writing a story about that. Well, as a journalist subscribing to this ethical norm of not being balanced, about not being biased, you would give the facts of the policy, and then you want to give the reader a sense of what the issues are, so you'd get some quotes to reflect what those issues are. And you might go down into Richmond and find some high-tech company CEO and get a quote from him or her saying that they're really excited about this new policy because it means access to cheap labor and a new market, and this is just wonderful, and they'll give some pithy quote to that effect. But to give balance, to give the readers a sense of what the issues are, you'll need a counter statement. So you go to, say, a union leader in Ontario in an auto making plant, and they'd give you a pithy quote about how they're concerned about the moving the manufacturing offshore, loss of union jobs, etc. So here's the story, here's the quotes, giving you the sense of what the issues are, and it's balanced. Now, let's take that into the field of science, and let's do a story on my cell phone dropping. Right, so you're going to write the facts of the story. Cell phone drops, fell down, accelerated at 9.8 meters per second squared. And then you want to get some sense of what the issues are. So I'm going to go to your physics department here, and get a quote from a physicist who's going to talk about how Newton was inspired to formulate the theory of gravity, etc. But to give balance, I need to go to the local chapter of the Anti-Gravity Society and get a quote from the executive director about how gravity really is a figment of our imagination, and in some parallel universe it goes the other way. So, I mean, it's an absurd example, but I argue that in fact in the field of climate science it's precisely what has been going on for quite some time in terms of the reporting of climate science. And that's illustrated here on a macro scale. That is, you give equal sides of a particular issue equal space in the newspaper. Shown here, Sunday, January the 14th, a headline says, "Study deflates global warming." Here 9 days later is the headline in the same Times Colonist. "Global warming severity grows." Like, what's the take-home message here? The only take-home message is that there must be this raging debate. It might be on, it might not be on, depending on the latest issue of Nature or Science journal that happens to appear. But of course, that's not how science works. There's also balance within equal space or within an individual article, microscale or macroscale balance. In fact, media interest also on a topic, media is fickle. Topics become timely or not. And you can look here in a number of newspapers, Calgary Herald through Toronto Star, Globe and Mail, Montreal Gazette, from 2000 to 2012 at the number of stories that contain the words global warming or climate change, and there's a peak in 2007. Climate change was the story. Record Arctic sea ice year extent reduction. You've got IPCC releasing a fourth assessment report. Lots of media coverage there. You have a combination of Al Gore's Inconvenient Truth, a couple of big weather events. And then global warming, climate change became yesterday's story. And now you start to see a tailing off of the actual amounts of reporting. But one thing I will say is that over the years, the accuracy has been getting better without any doubt, and that is beautifully illustrated by the by the September issue of National Geographic, where they actually got it right, and they show a line on the Statue of Liberty as to where the water would come if all of the ice in the world were to melt. And it's not up at the chest, which was the other one. It's about 200 odd meters there, and 150 is at the top of the base. Anyway, still to this day, not everyone agrees that the science of climate change is actually rigorous or even right. I'll give you some examples. This is my wall of hate at UVic, where I get lots of vitriolic diatribes emailed to me. And here's some examples. Have you dumb bastards read the news lately? There is no global warming, a-holes. It's been about money. And that's all just like everything else. It's only about money. As long as you could scare people into believing you're fraudulent global warming, you got lots and lots of money. Sea jerks. We're not as stupid as you retards think. So it gets better. This is a local commentator, Alex Sakumas, he says, "The University of Victoria should be ashamed to employ such a giddy huckster. He's a flatulent demagogue." I had to look up that. I mean, I didn't quite know what that meant. "Whose hysterical fear-mongering shouldn't be featured but investigated. After all, he receives grants to do his, quote, research." And this is where it gets a bit odd. "Still waiting for global warming, you disgustingly evil, lying, greedy scientists with an evil heart of unbelief are going to God's spiritual prison called Hades under the ocean job 26.5. I tell you, as soon as scriptures get quoted, I'm calling the police. In the belly of the earth with your will, intellect and emotions and conscience for 1,000 years of torment. Christopher Hitchens is there now, and he knows there is a God now. He's waiting for you, and David's so goofy." That's David Suzuki. And you can count monkeys together with Darwin, God abhors liars, blah, blah, blah. God hates the united abomination. It goes on. And I've even got my own protester here at UVic who stands out in front here and believes I'm a practicing liar because, you know, it's very odd. He thinks that somehow that by communicating climate science, by raising issues of global warming, or I think he thinks I'm involved in chemtrails too, that somehow I'm undermining God's will, and this is not good, and the rapture is meant to come soon, and this is me trying to stop that occurring. It's all very bizarre, but I do have this recorded on tape. So I do, it's just bizarre. Anyway, you have to realize, of course, that in any given issue around the world, there are people who have a diversity of views, and you will never convince everyone that it's something that's well understood in science is actually occurring out there naturally. And there really isn't much point spending all your time trying to to change the mind of individuals like this, because they won't change their mind. The actual science of global warming is not new. It goes back to Jean-Baptiste Joseph Fourier, 1824, who back then was the first to recognize that the atmosphere is relatively transparent to incoming solar radiation, but very effective at blocking outgoing radiation, and so keeps the Earth nice and warm, the greenhouse effect. In 1861, John Tyndall, known for his amazing sideburns, also developed an amazing instrument which was able to to measure the absorptive properties of a range of greenhouse gases, water vapor, carbon dioxide, methane, and others, and he was able to determine that some greenhouse gases were more effective at absorbing infrared radiation than others. In 1896, Svante Arrhenius was the first to make an estimate, a calculation of something known as climate sensitivity. That is, how much the world would warm if you doubled atmospheric levels of carbon dioxide. And he estimated that the world would warm between 5 and 6 degrees as a consequence of carbon dioxide doubling. 1936, Guy Callendar did the first multi-century projections of what one would expect to occur as a consequence of industrial activity, the combustion of fossil fuels, and warming. He made a critical assumption that he assumed that 1936 rates of CO2 emissions were held fixed in perpetuity, and as a consequence has projected that the atmospheric concentration of carbon dioxide would increase from 289 parts per million to 373 parts per million by the year 2200. Of course, then he calculated, as a result of that, that you get about 0.4 degrees warming relative to the 1936 time as a consequence when you rose to 330 parts per million, and about 6.6 degrees at 360 parts per million. These calculations have stood the test of time. They're very fine calculations. The only problem, of course, is that his estimate of 1936 emissions remaining constant clearly was an underestimate, and the current atmospheric concentration of CO2 is about 398 and raising by about 2 parts per million per year. In 1979, the science started entering the policy realm, and you started to get these international assessments or national assessments, the very first of which was something known as a Charney report, which was headed up by a MIT scientist named Jules Charney, and that was tasked with assessing the scientific basis for projection of possible future changes resulting from human-made releases of carbon dioxide into the atmosphere. And here's what they found. They found, based on the available evidence, that the best estimate of how much the world would warm as a consequence of doubling CO2 was 3 degrees Celsius, with a range of between 1.5 to 4.5 degrees. That was in 1979, compared to Arrhenius' estimate in 1896 of between 5 and 6 degrees. So brought that down a bit. The very first coupled atmosphere-ocean climate modeling study, one using these complex tools, these so-called models to make a long-term projection, had a best estimate of estimated around 2.9 degree warming for doubling atmospheric carbon dioxide levels. In 1990, the very first Intergovernmental Panel on Climate Change Assessment was released. And at that time, the best assessment, this is 11 years later from the Charney report, was that the best estimate of climate sensitivity was between 1.5 and 4.5 degrees. The second assessment report, this is when I started to get involved, was that climate sensitivity was between 1.5 to 4.5 degrees. That's in 1995. In 2001, the third assessment report appeared, and there the best estimate of climate sensitivity was 1.5 to 4.5 degrees. You see the media interest, 2007, big hoopla. Maybe this is what the hoopla was all about. In 2007, the best estimate was 3 degrees, unchanged from 1979. But now the range was 2 to 4.5 degrees. So a little subtle change there. But now we are in 2013, and let's see what the best estimate of climate sensitivity is from 30-odd years, or 30, I can't add at this time in the morning, along several decades of, I'm tired, several decades of research. It is 1.5 to 4.5 degrees. So we've had hundreds and hundreds of studies by thousands and thousands of scientists around the world for decades working on this problem. And frankly, in science, you don't get ahead by publishing papers saying 1.5 to 4.5 degrees 30-odd years after it was first done. You get ahead by finding new knowledge, as in any field of science. So the science is well understood. The science has been, people have been working on this for quite some time. It's not new science that was dreamed up by when, in the last few years, and it's certainly not science that was dreamed up as a socialist conspiracy to transfer wealth to the developing world. What is the problem then? Well, we know that the world is warming. The evidence is unequivocal. There's multiple lines of evidence from multiple sources, one of which is the NOAA, National Oceanic and Atmospheric Administration in the US, which collects world data and shows here the warming relative to the 20th century average from 1880 through today, and it goes from colder to warmer, but not in a straight line, nor would you expect it to be in a straight line. A lovely analogy of that is if you're at the bottom of a hill at a pub and you're walking home to your home at the top of the hill and you've had a lot of beer at the pub, when you walk home, you're not walking home in a straight line, you're staggering a bit, maybe 3 steps forward, 1 step back. It's the same thing in the climate system. You're going, there's a lot of water in the ocean, and that water moves and the heat's in the ocean, so as we're warming, the ocean's sloshing around and it's going up, forward, back, forward, back. So the trend is warming, but it's warming in a non-straight line because we have so much of our world covered by water. If you look at the top, I put top 11 because number 10 is tied. Top 10 warmest years, or 11 since 1880. Warmest year on record is 2010. The second warmest year is 2005. Third warmest in 1998. Many people don't realize, but 2013, last year, was actually the fourth warmest year on record, tied with 2003, and so forth. So if the world is warming, we should start to see obvious ramifications. When you warm, ice melts. No-brainer. So let's go look at that. Well, you could look at annual ice extent in the Arctic, as shown here, from the 1979 to today. Again, it's just the same. It's not a straight line down. There's a trend. It goes up, down, but the trend is clear. The trend is towards diminishing ice in the last few decades. Also, multi-year ice that lasts in the Arctic for more than 1 year. The amount of that has been going down, and as you would expect, the ice thickness, the average thickness of the sea ice in the Arctic is going down, and at the same time, the melt season, the length of the melt season is going up, just as you would expect. If you then ask the question, what will happen to the ice? Well, what you have to do there, of course, is start exploring these complex atmosphere-ocean coupled models, which solve the equations that govern the dynamics of the ocean, the atmosphere, and their interaction, as well as the chemical exchange of various gases. And you solve them on the computer, and the first thing you do is you compare your computer simulations today, which is the top, to reality for February and September, and they're not bad. But then you ask the question, what happens in the future? Bottom left, bottom right. In simulations where you make relatively benign growths, frankly, we're more on the right than the left in our trajectory. Benign growths in greenhouse gas emission and stabilization, you find that there's very little ice in September by the end of the century. And in the trajectory we're on, there's actually no ice left in the summer at the end of this century. And in fact, that's something that's almost certainly going to happen in the lifetime of many people here, as the Arctic will be ice-free in September as a consequence of greenhouse gas emissions. Other things we should start seeing. You melt ice, you melt frozen ice, you start to see permafrost melting. Well, there's ample evidence of this occurring, and this raises, it's a real planning issue if you're planning and building infrastructure, built infrastructure on top of frozen land. You're seeing it in many places in the Arctic, both in Alaska, Canada, and in the Arctic in Asia, in Russia, Siberia. You're starting to see some of the places where you get these so-called drunken trees, that because they grow on top of permafrost and the permafrost is melting, they start to tip, or the active layer is deepening, another way of saying that. And you're seeing enhanced coastal erosion in many of these regions as a consequence of the decreased ice extent, then allowing more wave activity on the coast to erode more exposed regions of melting permafrost. You're seeing roads in certain regions having issues, railways in certain regions having issues, and the one I love most is pipelines in certain regions also having issues. And again, as you would expect, the same model suggests that melting permafrost will continue to go melting on its way for decades to come. So now the question then is, what about climate change? I mean, we talk about climate change, natural or not. Well, actually, we as a community, we can actually there are ways and means of asking the question, is it natural or is it not? And the answer, without going through 3 lectures in a graduate level course, is that global warming, the effects of it can be detected in temperature at every region around the globe, with the exception of Antarctica. Even there, it's parts of Antarctica it can be, but other parts no. That is, we can say that there's a human influence that has caused warming on the regional scale in every region of the globe. But another way, a more relevant way for people to see this or experience this as individuals is to say, you know, how would we expect to see this manifest itself? Global warming is kind of, it means globally warming with time, but that doesn't mean warming in Vancouver or warming in Winnipeg in any given year. But there is a lovely way of illustrating this, and this was done by Jim Hansen 2 years ago, where what he looked at here, this looks like a bunch of dots, and it's meant to look like that. He asked the question, is our summer extremes becoming more anomalous? And to do that, he defined an average relative to 1951 to 1980. And during that average, he determined what the standard deviation was of the natural variability. And then he posed the question, as we look at any given year, how much of the world is covered by warming that is greater than what you would expect at certain standard deviation levels? So what do I mean by that? If I go onto any of these figures, I would know that about 31 or 32% of the globe should be covered by warm temperatures that are about 1 standard deviation or more above normal. I would expect about 4.6% of the map to be covered by warm events that are up 2 standard deviation above normal, and another 4.6% with cold events that are 2 standard deviations below normal. I would expect 0.25% of any given map to be covered by warming events that are 3 standard deviations above normal, or cold events that are 3 standard deviations below normal. And then it's 0.006% for 4 standard deviation, and a bunch of zeros, 5.7% for 5 standard deviation. So then he looked at a couple of years. It's 1955, 65, 75, the 3 on the top. And the kind of percentages of the map that you would expect to be covered by 1, 2, 3, and 4 standard deviation cold and warm events is about right. That is, you see some cold anomalies, a small percentage of